What's up, guys? Coach Tucker. Bonus points if you know what the background of this computer screen, what that show is being referenced right here. And then that's not the show, that's something else. All right, so, wrong thing. All right, so, here we go. We're going to go ahead and start working into quadratics. So, quiz 2 starts off with solving quadratics by taking square roots. So, up here, you went into quadratics, talked about some of the properties of it. Really, you didn't really solve anything. You did, but you really didn't. This is really the first method that you learn for solving quadratics. Again, some of these videos are pretty good. The article is really good. Suggest looking at that. But let's just go ahead and click into this. And as like last time, I need to zoom that bad boy in. There we go. So it says, write the smaller solution first and the larger solution second. Find the zeros. So we're finding the zeros. So if you don't remember this, go back and watch the video. But zeros is another name for x-intercepts. Okay? So if that's what we're looking at, let's bring up the sketch pad here. So if you're looking at the coordinate plane, let me put this little stupid glove on too while I'm at it. Okay. So if you're looking at a coordinate plane, okay, let's put one right here somewhere. So if you're looking at a coordinate plane, okay, and you're looking at a graph that goes across it like that right there, okay. So where the graph crosses the x-axis, those are called x-intercepts. Well, in quadratics, we call them zeros, okay? So right there, we call them zeros. So I would put in parentheses x-intercepts. Okay? So when we're looking for it, we're trying to figure out where y is 0. Set that equal to 0. So you're doing the same thing we did before. We're solving for 0. So 0 equals negative 10 x squared plus 490. In order to solve an equation, we isolate the variable. In order to isolate the variable, we do the opposite of what's occurring to the variable, typically from outside in. So minus 490. Those cancel, leaving negative 10x squared. That is negative 490. Divide by negative 10. Divide by negative 10. Two negatives make a positive. The zeros cancel out, leaving 49 equals x squared. And to get rid of a square, you take the square root of both sides. So the square root of x squared equals the square root of 49. So x equals, and remember there's two roots, two of them. So it's plus or minus 7. So there's our answer. They want the smaller one first. That'd be negative 7 and then positive 7, okay? So that's how we solve using square roots. Negative 7, 7. There we go. See if it gets any harder. Not really. This one's pretty easy. You subtract 7 on each side to get 36. The square root of 36 is negative 6, positive 6. I want to see if I can find a little bit of a harder one. It's 36 again. Okay, here we go. Let's do this one real quickly. I mean, it's not really much harder, but we'll do it. So again, we're solving for x. We're solving for 0, but the y is already gone. So we just literally solve for x here. So 6x squared plus 1 equals 487. Minus 1, minus 1. Those cancel. 6x squared equals 486. Divide by 6, divide by 6. So x squared equals, and I believe that is going to, what is that, 81? 81? So then take the square root of both sides. So the square root of x squared equals the square root of 81. So x equals plus or minus 9. So pretty easy stuff here. Once you get used to it, it's not terrible. So negative 9, 9. There we go. Let's move on. Bop, bop, bop. Let's move on. Quadratics by taking square roots. A little bit harder. Here we go. Let's do this one. So again, Same process as before, solve for x. Write the smaller solution first. So we have x plus 5 squared minus 64 equals 0. So add 64 to both sides. Those cancel, leaving x plus 5 squared equals 64. We can't subtract 5 right now. We need to take the square root first because it's outside the set of parentheses. So we're going to take the square root of both sides first. So now this is where this is something a little newer, but it's still nothing terrible. Remember, square root of 64 is plus or minus 8. And then you subtract the 5 over, but notice what happens here. You have x equals negative 5 plus or minus 8. Okay? There's two different numbers here. So x equals, there's two different numbers. We could have negative 5 minus 8, which is equal to negative 13. Or we could have x equals negative 5 plus 8, which is 3. So there's our two answers there. Negative 13 and a positive 3. So again, just something very minute to notice there. Because the square is here, outside the set of parentheses, we're going to have to do the thing on the inside of the set of parentheses last, okay? So just something small for you to note. Make sure you know, what was it? Crap. Negative 13 and 3. Is that what I said? That's what I said. Same thing here. Set this equal to 0. Go from there. What would that be? 16 is 4, so we have negative 6 minus 4 is negative 10, and negative 6 plus 4 is negative 2. Same thing. Again, actually, round the two decimal places. So that tells you right there. Whoop, where is it at? There it is. That one you're going to get a decimal. So we'll do that one with you real quickly, and then we're going to be done with that. There's one harder one. There's one other one that I think will probably come after this one, but we're already at 7 minutes. If there is a number being multiplied here, first you add or subtract, then you divide by that number, or multiply by the reciprocal if it's a fraction. Okay, let's do this one together real quickly, and then we're going to move on. So we got x plus 7 squared minus 11 equals 0. The other thing I want you to notice about these problems, we're always equaling a positive number. If negative had been 11, you can't take the square root of a negative number. Remember that. So this would actually have no zeros or no solutions for this one. But we can take the square root of 11. So x plus 7 equals the plus or minus square root of 11 because we take the square root of both sides. And then subtract 7 to the front. So x equals negative 7 plus or minus the square root of 11. Which, if I type that in my calculator, that is x equals negative 7 plus or minus. It said round to two decimal places. And we can go ahead and round the square root of 11 to two decimal places because 7's a whole number, so we're good there. And I almost messed up there. 3.32 is what it looks like. So 3.32. So if we do negative 7 minus 3.32, that's equal to negative 10.32. If we do x is equal to negative 7 plus 3.32, that is equal to negative 4.32. So there's our two answers, negative 10.32, negative 4.32. So we'll type those in. Negative 10.32, negative 4.32. Oh, I messed up. What'd I do wrong? Oh, that. There it is right there. Go back. Let me show you what I did wrong. I don't mind showing you. I did something wrong. Won't be the last time I do something wrong on here. Look here. That negative 7 plus 3.32. I did some wrong arithmetic there. That's a negative 7 plus 3.32. That is negative 3.68 because, again, you're subtracting the two numbers, take the sign of the larger number. So I did some silliness there. Silliness. My gosh. Negative 3.68. That was terrible. Hopefully you caught that while I was doing it. Bad arithmetic. Bad arithmetic, Coach Tucker. Let's do this one. we're getting close to 15 minutes, so we're going to real quickly go through these. All right, so Seth solved the quadratic equation. His work is shown below with step 3 missing. What could Seth have written as a result of step 3? Square root. Square root. So x minus 1, we square root both sides. So x minus 1 is equal to the square plus or minus 6, because that's the square root of 36. Hopefully that makes some sense. Same thing here. It says no. In which step did etnine, I guess, make an error? So if we look, subtract 1, good. Dividing by 3/4 is the same thing as multiplying by 4/3. So multiply times 4/3 times 4/3. Cancel, cancel. You're left with that. So 27 times 4/3. 3 goes into 27 9 times. 9 times 4 is 36. There's our issue. So step 2 is where she made the error. So again, going through some arithmetic. I'll let you go through there. If you got any questions, you can email me on that one. Let's do this last one. I really like this question because I have a feeling this is the type of question you're going to see on a TN Ready test. This is something you will see on a lot of online testing, okay? ACT not as much, you won't. But ACT is starting to look to go online too. And so a lot of these online tests, this is an excellent question they can ask you where you really are not doing a ton of like calculations. You're just telling them what steps to take. For instance, if we were to solve this equation, you would subtract 2 first. So put subtract 2 over there. Then you would multiply times 2 or divide by 1/2. Well, we don't have divide by 1/2. We have multiply times 2 because remember, dividing by a fraction is the same thing as multiplying by its reciprocal. Notice we're not even getting our calculations. We're not figuring out minus 2 times 2. We're not doing any of that. We don't have to. We're just being asked to, what's the steps? Now you would take the square root of both sides. So square root of both sides. And then you would be left with that. So we would subtract 5 from both sides. That's it. Like this problem, they're not hard. They're asking you, what steps will you take to solve the equation? Here, you wouldn't subtract or add first because you don't have anything to subtract or add, but you would divide by that 3 on both sides. So we'll bring it over there. Then you would square root. You got to get rid of that square because you can't subtract 2 yet. It's protected within that pair of parentheses. And remember, you're kind of working backwards usually from the order of operations. So we would take the square root of both sides. And then from there, we would subtract 2. There we go. So, again, that is the section solving quadratics by taking square roots. Pretty good. I hope it made sense. This is easily the easiest method in solving quadratics. It's not always available to us. But if it is available to us, we definitely need to take advantage of it. So hopefully that video helps you whenever you're working those problems. Thanks.